Hi, okay, let's go ahead and, I thought I'd go ahead and put together short videos for you guys to review. We'll talk about this stuff in class, but you can come back and take a look at this. The first part of this video, or maybe the initial video, will be about Linux and the OS and platforms and such, and the second part about a few of the commands. I might just tie together depending upon time. So, this will probably be as easy as anything. Uh, we're talking about Linux as an operating system, and you guys have learned about operating systems, I'm sure, in other classes. The how Linux is built. So you have your operating system built here. You have all of these hardware components: the monitor, the keyboard, drives, all those things that interact with it. So this Linux is that operating system, and of course we have programmers and application programs and users that interact with the operating system. So you can think about this with Windows. For instance, in our case, what we're going to be doing is, if I can bounce back and forth to right here, this is our operating system, and the hardware components will be under Manage and Virtual Machine Settings. These are all those hardware components, and they're set up virtually. So let me minimize that. We'll come back to here. All of these components are set up virtually. The hardware, or the CPU, is virtual. The monitor and the mouse and things are from your own, from the host computer. And then the operating system is Linux, and we are interacting with it through, of course, the graphical user interface initially, but through the command prompt typically. Okay, quick and easy: personal computer, PC, standalone computers, basically. Your laptop is that. Now, a platform, though, is a combination of hardware and the operating system, and sometimes the applications. It just depends upon the context. In a business setting, you might have Oracle running on a Unix mainframe or a Unix box that's using an Intel processor. And it might be kind of a high-end PC or a workstation. So that's your platform: Oracle and Linux running on a high-end Intel server. The platform combination of hardware and software. In our case, we will be thinking about a platform as a combination of the hardware, which is basically an Intel sort of platform, is what this virtual machine stuff does, and the operating system being Linux. Now, so obviously, you guys know this. Computer network lets PCs share resources. A couple of different things we've talked about a little bit. We'll talk about more. But a client-server environment is typically one that you'll work within. So the server operating system controls the operations of the server, and then the clients just simply access those services on that server. A good example is through your registration system for MyCarroll. Your client, and although your client is running the web and HTML through a browser, basically all the processing is happening on that server. You're going out and accessing that MyCarroll server and requesting pages, requesting information. All the processing is happening out on the server, and the MyCarroll server is simply sending you back information. Now, conversely, peer-to-peer networks, and it's just something that there's a use for it. There's a use. Oh, and I'm thinking about probably in systems where there are a lot of high-end processing, maybe CAD/CAM sort of systems, computer-aided drafting, machining sort of systems, where the desktop itself is really that platform that provides a service, and you might be saving files out to a server, but the processing is happening on the box that's local. So, but a peer-to-peer network are an alternative to server-based networks, and each system is both a server and a client. So usually they're just tied together very simply. All right, Linux and Unix. So Linux is not Unix, but Linux is Unix-like in its operating system. It's not written from the traditional Unix code, and then there's a kernel created to look and act like Unix, and then Torvalds released it free of charge back in '91. So Linux has been around for a long time. Again, it looks like Unix. It's not quite built the same way, but it really functions that same way, and that's the whole idea behind it. You can go from a Linux box to a Unix box to a VMS box, and VMS really isn't used that much anymore. With really very little with very little difference. The biggest problem is actually flavors of Linux. Those flavors being things like Ubuntu, which we're using, Red Hat, SUSE, Debian, damn small Linux, and so on and so on, that are just a little bit different in nature. They work just a little bit differently. That's probably the biggest problem. Now, a shell is a program that interprets commands that you enter from a keyboard. Okay, so when you log in, this is the shell. This is the bash shell that you're going to be working within. Okay, so once again, shell is a program that interprets commands you enter from a keyboard. This is that bash shell. You can change the shell, but typically we'll just use the bash shell as the main shell that we interact with. Let's see, graphical user interface, that's the GUI, that's of course all of this. And we'll be working from a command prompt. So just briefly, quick history, you can read this mostly for yourself. Developed way back when. A couple of different standards evolved. System 5 from Bell Labs and BSD from Berkeley. And then Linux might be considered a more integrated version of Unix than its predecessors. And so on and so on. Just remember that Unix was developed way early on. It ran on mainframe systems typically. It ran pretty well. It was very secure. VMS actually was Unix-like, and it was more secure, but Unix was very secure. I've heard people talk about in the early days of Unix that there were memory leaks within it, and if you had a box that would run a mainframe providing services out there, if it would run for 30, 40 days, that was pretty amazing. So Unix no longer has those particular kinds of issues. Just remember, every operating system that you work with has issues at one point in time. And Linux, or Unix I should say, had memory leaks way back when. Alright, Unix and Linux OSs. So Linux can be servers, they can be clients, they can be workstations, it can be standalone workstations, so it can do all of those functions. And then it's a multi-user and multitasking system, so remember that. Windows is, Linux is, and then some of these characteristics of Linux, and I'm kind of saying Unix/Linux, they're similar. Unix you'll see on bigger boxes, Linux can port down to smaller boxes. Portability, stable, it's reliable, it's versatile, lots of applications, a lot of security options, and it really works well in network environments. So these concepts, let's see out here. We have the hardware. Now remember, in our VMware configuration, it's virtual. But we have our hardware. Then we have the OS, and that's referred to as the kernel. The operating system is called the kernel. And then we have our shells, which is like that bash shell. Oh goodness, goodness, goodness. Okay, we have our bash shell that we can work within. So on and so on. Okay. Oh, let's go back out here to, there we go. And then we have those users that will access the system through those shells. Okay. Now, Wine is an open source implementation of the Windows API for Linux. So this enables you to run Windows programs on Linux. An API is, again, an application program interface. You can drop Windows applications on Linux and run those through the Wine program. I haven't tried this but a couple times, but that compatibility, that versatility is really important within this environment. Having a smaller footprint, smaller resource footprint, it should run pretty well. Any other application should run well. That's something we should try. Okay, connecting, I'm not going to really worry about this. You can SSH into it, though, into Linux remotely. You guys, the same idea is you're using VMware to remote in, basically, to the campus. you can do the same. It's the same idea, but you can use SSH as a secure connection to Linux and remote login. Commands, case sensitive. In this case, the example was John differs from John with the uppercase to the lowercase. Let's see, user level commands. You'll use these commands in class. System administration commands. Typically, we won't use those a lot. We will use some. Those that we do use will run from sudo. So that's the system or super user interface. Let's see. So first of all, let's see. I'm going to pause this for a bit, then come back with more specifically these commands and examples. Okay, I think I repositioned this well enough. We're looking at the who command, and a lot of these commands in Chapter 1 and even Chapter 2 are pretty straightforward. The who command determines who is logged into the system. So we'll type in who, and then we can just see me as the user on this system. On the mainframe system or on a server system with lots of people logged on, you'll see a whole list of users probably. Now, if I want to look specifically, I just type in who am I and I get my specific account. Once again, the difference, who, it's everybody that's on the system. Who am I? Me specifically. Now again, I'm going to pause and kind of bounce around here a little bit so I can place everything that I need to on here. There are some additional parameters on the who command to show column headings with a capital H. That has to be a capital H. A small case U to show idle time for each user. Idle time meaning time that they're logged in but they aren't doing anything. Q is a quick list of the users who are logged in, and -B to verify when the system was last rebooted. So I think we should be able to go who-B. System boot was 146 today. So you can tell when a system was rebooted, who-H. And I'll scroll down just a little bit here, or move this up a little bit. It gives me those column headings. Okay. The man program, it's the manual, sucks. But with that, sometimes you might not have Google to be able to ask questions to. So, and if we go down to here, and you can see it was man. Oh, no, how about this? Man who. So what we want to do is use the manual and get information on the who command. And then so it gives us all the information. You can either press spacebar to go on, or you can press Q to quit. Pretty hinky. That's the way it works though. Also, command line editing is hinky. It sucks. Typically, you would use an editor like VI. Better yet, you'll probably use an editor like gedit. So let me, and I think I've got the right programs out here to do this. So initially, when they want you to make a program, they might have you go to, let's see, file 1, redirect that input. Oh, hold on. Let me come back to that just a sec. Okay, there we go. Kind of cleared up there, I think. So command line editing. So like I mentioned, it's difficult to edit in command line. It's just something that you have to do in Linux sometimes. We're probably using a text editor. What they're going to have you do initially is create files right from the command prompt. So there's a variety of ways to do that, but I think one of the ways they go through is cat. The greater than sign is redirecting output, and we're just going to make a file called stuff. Just gives you a blank line here basically. This, that, the other, a Control D. Control D will go ahead and close that. Now if we type in ls for list, we can see stuff. If we cat for catalog, C-A-T, stuff, we can see what is within that file. Okay, so another way you can edit those files, VI stuff. And VI is a basic dumb text editor. difficult to use. Chapter 3 talks more about this. We'll go ahead and just hit escape, colon Q to quit. It goes into the extended editing mode, and we can quit out of it. Didn't change it. And I think gedit, I'm already started. Gedit stuff is a text editor that's more of a notepad-like text editor that you can go ahead and edit this with as well. So I haven't used this in on Ubuntu yet. So I'm going to go ahead and close it, and that's all about text editing. You can also add multiple commands to the command line. Let's do that right quick. So this is just with what we have so far. We're going to list stuff, and then we're going to add dir stuff, which gives us the output. Well, let's go, list stuff, which gives us that output. Dir stuff, that gives us that output. Let's do it this way, list -l stuff, which is a long output. So we can see the difference. Let's list stuff. We'll add a command, -l stuff. And so we can see the first command was ran and the second command was ran. So you can add multiple lines by adding commands together, or have multiple commands by adding the lines together using a semicolon. You can get the previous commands just by up arrowing. So I'm up arrowing right now. It's handy dandy. You'll use that all the time. Get used to that. More or less can display the beginning and ends of a file. Especially it's handy especially if it's a long file. Exit to go ahead and log out here. Now redirecting output. So remember we have this. We have cat stuff. We can see what's in stuff. So if we cat stuff, more stuff, let's see what we've got. There we go. We added by the double pipes, or double greater than signs, is appending. So a single greater than sign is redirecting the output. Double greater than signs are appending it. So we had this, that, and the other originally, and then we appended more stuff. And there it is. So I think finally in the end we have a command summary in our presentation. We have more command summary, and I think that will go ahead and conclude chapter 1. I apologize for the length of the video. Cut it apart, take whatever you need of it, and there we go. So